Hi again, this is part 2. This time we're going to develop the engine. The engine is going to determine, let the computer determine what is the best move. So, let's see, okay. So we start with the test, and this time we call it engine spec. Okay, the namespace is ttt engine dash spec. And we do the same thing, require macros. The speckles core, we still need the describe context it should equal. Okay, and then require speckles core and ttt engine. We'll probably need stuff from position. We'll start refer, and I'll just make it into an empty list for now. I will add it when we need it. Okay, so the main test, okay, for engine context is the minimax. Okay, we're gonna do some tests for the base cases. So it determines, okay, it determines a win for x. Okay, so it's gonna look like should equal, let's say 100 is the score that we want if it's a win for x. We'll set the position here later for x. So that'll look like that. So this is a win. So the person has already won, and so actually this is not correct. It should be we're testing minimax. So minimax of this position. Okay, don't need this. Okay, so let's see if we have this right. Should equal 100, this minimax, given this position. All right, so that should equal 100. Okay, so let's get this to pass. Save, and of course, we're going to get a big error message because the file doesn't exist, so we're going to create it. Engine, okay, create the namespace. It looks like it passed, but really the error message, the important error message is right above it. It says that it couldn't find ttt engine, and so when the test is run, it's using the old ttt-dev.js because since it couldn't find it, it didn't compile a new version. Misleading. Somebody ought to fix that. Okay, so ns ttt engine, and I'm going to need to require some stuff from ttt position. I'm just gonna like forego that for now and just add that in when we need it. So we need minimax, and it takes a position. And I'm just gonna leave it like this for now, and I should have a failing test. So let's see what kind of failing test we have. Determines a win, undefined object, minimax. So here's minimax. Oh, that's because we didn't import it. Minimax. Okay, so let's see. Now the error message. Now we have a better error message. The error message is expected 100 but got nil because we didn't write any code for it. Alright, so now we're going to write something. We could actually just do that, and that should make it pass. Alright, great. Passed. Okay, next test. For x, for O, it should be negative 100. So we'll change all these to O's. Get rid of these trailing spaces. Okay, Just do it like that. Okay, so now this should fail. All right, so we could see here that for X it's green, for O it's red. So let's go do that. So cond is a generalized if. So if we need to do a decomposition here based on the keys, board, turn, and we name it position. Oops, as position, like that. All right. So we need to check the turn. If it's X, then we're going to say it's 100. And this actually should be like this. So if it's X, return 100. If it's O, return negative 100. Hey, it passes. All right, next. Okay, so remember these are base cases, so we're not doing anything complicated right now. We're just doing some checks. So we have a win for X, a win for O, and we should determine a draw. Okay, and how do we know that it's a draw? Well, you've gone through all of this, and we definitely know that X hasn't won and O hasn't won. And if you run out of moves, then it must be a draw. So for draw, we're going to assign it a value of 0. So let's create a draw position. Okay, so this is a draw position because no one has won. So we save, and expected 0 got negative 100. That's very interesting. That is very interesting because I was expecting a nil, because here it shouldn't have passed this. Oh, the reason why is because I just checked the turn. What I was supposed to do is check to see if they won. So my tests were wrong. It should really be okay. So if X wins in this position, it's 100. If O wins in this position, it's negative 100. So this is the correct behavior. Now let's see. I had some warnings there. Oh, the warning is because I didn't import. I didn't import the win function. So let's do that. Let's see. I'm drawing a blank. Require macros. Okay. It's good to have completion. Require macros. By the way, I did Control-N to do that completion. Okay, require macros. I need it from TTT position, and I need to grab refer win. Okay, so now it shouldn't complain. Oh, actually, I was wrong. It's not macros. It's just require because, yeah. All right. Much better. Okay, this is what I expected. That the return value is nil. So expected 0 got nil. So we have to write a test, a testing condition over here. Okay. So how do we know if it's a win? If the possible moves of the position, if that's empty, if there are no possible moves, that's how we know. We're probably going to be using possible moves a lot, so I'm going to put that in a let. So I will wrap this up and say let moves be possible moves of the position. Okay, and then I'm going to replace this with moves. So if it's empty, then just that's a 0. Oh, lots of errors. Oh, that's because, again, possible moves. I need to import that. Okay, now it looks very nice. So I have everything here. Determines a win for X, determines a win for O, determines a draw. Okay. the next piece is the recursive part. Now, conceptually, this is more difficult, but all you need to know is that since you have the base case, we can use this. So we can assume that minimax works, and we build up from there. Okay, so let's write a test for it. The test that we're going to do is determines a win for x. So it looks exactly like, or should look exactly like the first one. As a matter of fact, I'm just going to delete this and just copy this one. Oops, wrong place. Should be here. Okay, determines a win for x, but it's going to be in one move. So what I'm going to do is take this out, and it's going to be x's turn, and the next move x, it should realize that this can win, and so it should be 100. But it doesn't know about that yet because we haven't written the code, so that's why we're getting a nil. Okay, so now we're going to write the recursive part. So when we're writing the recursive part, we have to assume that minimax, the function, has already been written and that it works. And we have reason to believe that because the base cases are handled. And this is one case removed from the base case. So if an x was put over here, then it would be one of these base cases. So how do we do that? Okay, so we'll put in the else clause, and we'll start off with the moves. Okay, so this is a list of possible moves, and what we need to do is make a list of positions based on those possible moves. So that means we need a map and a function. That function is move, and we do this, the %, which means that this is a list of moves, and it's going to map it. So this function takes one move. That move is just an index. So it's going to move, that's the index, but it needs a position, which is the current position. Okay, so this whole thing, starting from here to here, this is a list of positions. We could actually do a little bit more here. I'm going to wrap this up and call minimax on this. So what this does is it'll take a position and find the minimax value of it. Now this is not the current position, this is the next position. And the next position is going to be one of the base cases. So this is going to return you a map, and then we're going to find the max of that. But we can't call max like this. Okay, let me show you. So let me run a REPL. REPL is read, evaluate, print, loop. Okay, so in this REPL, max of 1 and 2, and that'll give me 2. But that's not the way we're calling this, because this is going to be a list. So it's like calling max on a list. And that just returns back the list. What we really need to do is apply max to that list. And so this, it would be the same as calling it like this. So when you say apply, this max gets put into the list and then it gets evaluated. All right, so that means that it's really apply max to that list. Okay, so let's go back here. And then I'm going to have a value. Let's see if that works out. It runs, but it has a problem because, let's see what the error is. Undefined is not an object. Move. Now again, we need to import move. Okay, run it again. It runs, and it's taking a bit of time, and then it passed. So it worked. Okay. Now we're going to modify this a little bit. Instead of 100, we're going to give it a little penalty, because when you have a choice of possible moves, we want to choose the one that leads to the shortest win. So we don't want to just delay the win. We want to get the first win. Okay, so how do we do that? So we're going to do that by giving some extra bonus points for the number of possible moves. So if you have only one possible move, that means you went pretty low down the game tree. But if you have a lot of possible moves, that means that you're finding a win that's very early. So we're going to do a little arithmetic here and just add. Okay, and we're going to add a count of the possible moves, the moves. So this way, you get some bonus points if you have a lot of possible moves. If you have no possible moves, then it'll be a 0. So let's see what the value ends up being. Okay, it's running. Okay, you see this is kind of slow. We're going to fix this up a little in the next, probably the next test. Okay, it says 128. Okay, well, I know that's not a good number to use because that only does maximum. But what we need to do is do the other side, which is a win for O in one move. And that should be negative 100. Well, it's going to be the wrong answer, but it's going to be working correctly. Okay, so for here, now it's going to be balanced. Okay, it's still taking some time because it has to do the calculation. And okay, the first one failed and the second one failed, but okay, we need to modify this because we're not really doing mini max, we're just doing max. So the way it works is, okay, I'm going to import choose because choose based on the turn. If it's X's turn, I want to do plus, otherwise I want to do a minus, because when you're doing O's turn, you want to go negative. And over here, we do choose turn max, but for O, we're going to use min. And we keep the rest of it the same. Okay, so mini max, everything else looks fine. Okay, so we save. So the algorithm here is correct now because it accounts for both finding the minimum and finding the maximum depending on whose turn it is. And so these are the values that we're going to be using. So in this way, it's kind of backwards that we're running the program and setting the test. But if you really wanted to, you could use pencil and paper and figure it out. But it's probably a lot easier to let the program do the calculation. All right. So now this all passes. Okay. This is sufficient to make sure that the minimax is working properly, but it's kind of slow. So we're going to fix that. We're not going to add a test this time. We're going to just do a refactor. Okay. So Clojure has this really great thing called memoize. And so I'm going to memoize it. Memoize means that it remembers the return value given the input parameters. So I'll do declare minimax. I'm declaring it, and I'm going to define it later. And for this, I'm going to just change the name to store minimax. All right. Then the actual minimax is minimax, memoize, store minimax. So what this does is it'll take this function and remember all the input and output values. So like once it does one calculation, it's stored. So it doesn't have to do the same calculation over and over again, which actually happens when you're doing the tic-tac-toe. There's a lot of redundancy. So memorize is going to speed that up, and any answers that it generated, that it calculated, is going to cache. So that's it. That's all you have to do is because this is calling minimax, but minimax is going to call store minimax, and they're working together to kind of do the caching. So let's see. Now this should be a lot faster. So you can see already that the return happens a lot quicker. Okay, so we actually did the memoization. That's done. Okay, so the next test, actually we're done with minimax, and we're going on to the next method, which is best move. And this is the important one. This is the one that we need, the best move. Okay, so it determines, oops, the best move for x. Okay, so how does it look like? Should equal, okay, so let me do bt2. So given this position, I'm going to call best move. Okay, I'm going to call best move on this position. It's x's turn. And because it's x's turn, the best move is 2. 0, 1, 2. Okay, so 2. Best move of this position should be 2. All right. Now I'm going to get an error because I haven't written that code yet. So see, best move, and then go to here and let's start writing the best move. Given the and I'm going to do the destructuring, keys, board, turn. I'm not sure if I need all of this, but I'll remove it if I don't need it. Okay, so the best move. Okay, so now I shouldn't have that long error. I should just have a failure. Okay, now I have a failure. Okay, got 2. I mean, got nil, but it was expecting 2 because I haven't written any code. All right, so let's write the code. I could just do 2, but let's do something real. We have minimax now. Now, what we need is max key. I'll show you how max key works. So here's, okay, you saw how max works, but if I say max key and I give it, let's see, 1, 2, and 5, 1. Okay, so this is, okay, and it requires a function. So let's say that I want it based on the first criteria. So I would say first. So I give it first is a function, a predicate. So it's going to extract the first element. So it's going to do it based on the first. And so max key first. Oh, that's because it's expecting it to look like this. Right. So it chose 5, 1 because it looked at the first one and saw that 5 is bigger than 1, and so it returned that element. If I had based on the second one, it'll return me the other one because 2 is greater than 1. So here 2 is greater than 1. Okay, and so our code is going to look very similar to this because what will end up is a pair. The first, you'll have the index, which is the move, and then you'll have the minimax value. Okay, and we want to base it off the first, but return, eventually get the last item. Okay, so let's do that. All right. So first we start off with the okay, we have minimax. So so first we start off with the list of possible moves. I guess it doesn't hurt to start off with a let, and moves is the possible moves. Actually, it should be possible moves of the position. Okay. All right. So starting with the moves. Well, let's see what happens if I just run it. Entertainment. Okay, so we know that you know, our choice is one of these. It's actually this one, but then we're going to do the filtering here. So we're going to modify this to map indexed, and so this will, okay, so map indexed, I'm going to do a minimax. Well, first I need to make a new position. So move position %. So let's see what that looks like. Actually, %1. Okay. All right. So it looks like a list of positions here. So you can see these are all the possible moves that were made. Okay. Interesting. It's O's turn. Best move. Let me just take a look here. Okay, best move, turn is X. Okay. Interesting. Okay. Oh, this is not correct. It should actually be like this, because the first one is the 0, 1, 2, the index of, actually it's not mapped index that I want, I realized. It's just map. Okay. And because it's just map, it only takes one parameter. Okay, I think that's correct. All right. Yes, this is more of what I expected, because you could see that the this move has been made. This move, the X is over here now, the X is over there. Now it's going through all the different positions. Okay, so that looks good. And all we need to do is just run minimax on that, and then we'll get the values. So let's do that. Here, we can't, actually, yeah, we can do, just run minimax on this, just minimax on it. Okay, let's see what it looks like. Okay, so we can see some scores here. And because it's X's turn, well, looking at that test, you can see it's X's turn. We're going to try to maximize. So this 100 is standing out. And so what we want to do is we want to associate this with the moves. So now I have two lists here. This list that starts from here to here, like this list here, represents the minimax value. Okay. And this here represents the index. So which is what we said we wanted. See over here, we said we wanted a minimax value and the second argument to be the index. But these are separate lists, and we can group them together using see, okay, map, see, map vector. map vector between this and this. Okay. So instead of having like a minimax value list and an index list, it'll look more like one list where the first one is the minimax value and the second is the index, and then you'll have a whole bunch of these. So it's a list of pairs like that. Okay, so this looks good. All right, if let's just see what this looks like. All right, so we can see now that for move 2, that's 100. And everything else is less than 100, and that's the one we want to pick. So now we can use max key based on the first. So let's run it. We should be very close. Oh, the reason why it didn't work is because this whole thing is a list. So we need to apply it. So this way it'll flatten out that list. All right, we got it. And all we need to do is just extract the move number. And we do that by saying second. Let's see. The test pass. Okay, great. So I'll do a little cleanup here because it's kind of wrapping all over the place. Here's the first list. This is actually this and this, and map key, apply max key on the first. Here is the list. Okay. Trying to see a better way to organize this, but first of this. Well, let's see, minimax map. I'm not really sure if there's any really good way to organize this a little better so it becomes more readable. Well, okay, so this works. I'll just leave it like this for now. Map vector. Okay. So we have only half the test because the other half is a test for O, the best move for O. In that case, it should be 3 because here's O, O, and this is the position number 3, and it should be O's turn, and this should fail. The reason why it fails is because we're only doing maximum, so we're looking for the best move for X, but this time we need to find the best move for O, and you do that by looking at this max key, and based on whose turn it is, for X it used the max key, but for O you use the min key, and everything else should look the same. So now we save, and we have a passing test. That means that our engine is complete. So we're able to find the best move for both X and for O, and we're done. So the next time that we meet for the next episode, part 3, we're going to finish it off by doing the user interface. So, and we're going to create the game and actually see the game in action. Okay, so see you next time.